Our mission is that as the start push button is pressed, the supply cylinder advances, and after 3 seconds the cylinder returns to its original position. So for this particular project we are going to use an on timer and adjust its preset time to 3 seconds, and we will get the following results. By modifying the ladder diagram of the above, and here the up counter is used and executes the task, that is, as the push button is pressed the supply cylinder advances and returns 3 times. After all, the supply cylinder stays in retracted position as long as the push button is not pressed again. Let's draw its ladder diagram inside GM-Win software. To do so, first insert project file name called cylinder control using a single solenoid valve, then make sure among the programming language it is ladder diagram, then finish. You can get all of these instructions on the right hand side corner, so select the tools among the existing ones and complete the ladder diagram. As you can see, we represent each of those input and output components as follows. Here, as you can see, PB1 means push button 1, whose digital input address is allocated at IX 0.0.16. Red pose means the cylinder's retracted position having a digital input allocation of IX 0.0.0. T0 means the on-timer output address, MX0 means the internal memory address, Y1 means supply cylinder coil tag, which helps to advance the cylinder piston having a digital output address QX 0.0.0. ADPUS means the advanced position of a cylinder digital input having address of IX 0.0.1. PT in the on timer means preset time, so we need to set 3 seconds, so place T #3s. After completing this ladder diagram, compile the program. So compiled successfully, then go to Online Connect, write Run Monitor on, then upload the program towards to the GM-Win PLC module. As the status depict make completed and linkage is successful. By default, the cylinder stays in retracted position, and when its coil tag gets power supply it becomes activated and now advances its cylinder pneumatic piston. Unless it will stays in retracted position. From the ladder diagram you are looking at, to energize the coil tag or advance the cylinder piston is depends upon the on timer normally closed contact and push button 1, in addition to its retracted state of the piston that have been set. As the start push button 1 is pressed, that would trigger memory address MX0 and self hold its coil and immediately advances the supply cylinder, and now the advanced state of normally open set of contact enables the input pin of an on timer, so now the timer output pin remains off until its preset time, which is 3 seconds, reaches. Then this will helps to de-energize the pneumatic piston and return its piston to retracted state. We are able to see the ongoing process in a simulation manner on a serial monitor. By modifying the ladder diagram of the above, and here the up counter is used and executes the task, that is, as the push button is pressed the supply cylinder advances and returns 3 times. After all, the supply cylinder stays in retracted position as long as the push button is not pressed again. It is similar to that of the previous one with the replacement of the on timer by up counter. Here PB1 is the one and the only push button which is provided with the address IX 0.0.16. Repose is the supply cylinder retracted position sensor provided with the address IX 0.0.0. C0 means the one whose coil tag is connected to the counter up output pin. Here 3 memory address MX0, MX1, and MX2 are used. ADPS is the advanced position sensor of a cylinder with an input address 0.0.1. Pneumatic synchronization with advanced programmable logic controller PLC programming solutions offers a reliable and efficient way for discrete parts manufacturers to control their production lines. By connecting compressed air cylinders to the PLC through a timing mechanism, the system can be easily programmed to accurately and consistently repeat machine motions or cyclic actions. This is especially valuable for manufacturers who require precise gestures and repetitive movements during part fabrication. With all these benefits combined, PLC pneumatic sync programming will significantly reduce production costs while improving overall product quality in automation applications. As it is shown, the push button is used to reset the up counter that resets the current value of a counter to 0 as it is pressed twice, and so forth. After it reaches preset value and try to exceed, here for a counter we use 3 as a preset value. At last the supply cylinder coil tag Y1 have given the output address of QX 0.0.0. So to trigger the coil tag of a cylinder piston, the first memory address MX0 needs to be energized and the second memory address MX1 not needs to be energized, meaning it should stay in the energized state. To understand what is going to happen as the push button pressed? Well, as the push button pressed once, the first memory, which is MX0, gets supply from the rang and self-hold its circuit. Now it is independent of whether the piston is in retracted position or the push button is pressed again, and as I have said earlier, the only thing that is left to activate the supply cylinder is MX0, which is now made and it is energized, so which changes the cylinder piston from retracted position to advanced position. This helps the second memory address MX1 coil tag gets energy. Due to this reason, on the other side it disrupts the cylinder piston activation, so that will tend to retract. As a result, the third memory address MX2 is the input for a counter to count, and as we see from the ladder diagram, it depends upon the memory address MX1 and the cylinder's piston to be returned. This is detected by retract position sensor. This is achieved through when MX1 and retracted position sensor detection senses those two important effects to be made, and helps to detect those effects and allows the supply cylinder piston on off 3 times, and due to in an interlock manner connected normally closed set of contact of the up counter output that results in to cease the overall program. So if the push button is pressed for the second time, it will results in 2 things. The first one is to reset the counter's current value to 0, and the second one would repeat the previously expressed execution. Thank you very much, and don't forget to subscribe and share the video if you find helpful. Stay creative. This is PRD-SS channel.